Okay, now this is a very short film on finding the focal length using all the correct equipment. Yeah, I could use the glasses, I could use a spoon, but actually I'm going to use the proper stuff that I was meant to use. A lens, as you can see, a concave mirror, a ruler, and the white box is what I'm going to use as a screen. So first I need to slightly darken the room. Then what you have to do is find the approximate focal length. This is just to start the experiment well and so you don't make a complete muck-up. You focus a distant object onto a screen, and the distance between the screen and the lens then is exactly the same as the focal length. Of course, if you have a convenient fighter plane, well, maybe you should use that. Having made sure that I place the lens more than 2 focal lengths from the screen when I did the approximate value, I then introduce my light and I move the light back until you can clearly see there a sharp image appear on the screen. Now I can move this screen and it will give me a different value. There. Perfect. I then have to measure the distance from the light to the lens and call that U, and from the lens to the screen and call that V. So to recap, you get your sharp image and then you measure the distance with a ruler from the light to the lens, and that's U. I've got 23 here, and then from the screen to the lens, and that's 18. Now you can, of course, also do this experiment for, in this case, a concave mirror. The concave mirror will also do it, but you're reflecting a light, as you can see by the straight change in arrangement. You can measure V and U again and do a calculation exactly the same. Now, once we have it ready, once we have our whole thing set up and we have our 2 measurements, we start talking a lot slower because we're doing a calculation. Once you have the U and the V, finding F, the focal length of the lens, is comparatively simple. You look up in the logbook in the light section and you find something called the lens formula, which looks like this. Now, because of all the reciprocals, it's probably the hardest formula to use in physics. So we'll start with this, shall we? Now, the U values we obtained, the first one was 23. So we rewrite the formula with U being 23. That's in centimetres. The equivalent V value was 18. Now, I'm not going to bother with trying to teach you how to do fractions. I'm going to do it here on the display. So, right, press the button to make it a fraction. 1 advance 23. We add that. We press it again. We have 1 advance 18. Advance it and press the equals sign. This gives you a value of 0.099. So I add the 0.099 there, but that's not the value of F. That's the value of 1 over F. So I have to press the reciprocal button, which looks like this. X to the minus 1. I press that button, if you can find it, and then I press the equals button again, and I find that the answer is 10.1 centimetres. So 10.1 centimetres is the focal length. Now I repeat this for each of the pairs of readings I've got, and I'll get 3 different values which should be close to each other. And I then find the mean in the usual way by adding them together and dividing by 3. If I want to find the magnification, I use this formula, also in the logbooks. This formula is for magnification. In this case, the V is 18 and the U is 23. The 2 lines of course mean that it doesn't matter what sign they are. They're called modulus lines. And that means that it's roughly 0.78, which means the final image is about 0.78 the size of the original. Well, if you remember the picture, you'll see that the image of the light was slightly smaller than the actual light itself, which bears with this calculation. Now what I want you to do is to do the question I'm going to set, which is a normal exam question, and hopefully you can get some similar mathematical results.